Well, let's begin this video by recalling that the probability of E given F is the number of elements in E intersect F over the number of elements in F. So you just take the intersection of those two events, take the number of elements in that intersection, and then the denominator is the number of elements in F. You can also write that with capital P's instead of little n's. If you already know the probability of E intersect F and the probability of F, you can just plug it into that formula. Just make sure you either use n on top and n on the bottom, or you use P on top and P on the bottom, the probability. Okay, so we knew that from a previous video. Now that gives us the multiplication rule for conditional probability. So I'm going to use this part here, okay, and this. So for now I'm going to ignore the middle part. If I want to get the probability of E intersect F all by itself, I would multiply by probability of F, both sides, right? So I'm going to write this down as the probability of E intersect F is equal to the probability of F times the probability of probability of E given F. So we really, all we did is just a little bit of algebra on this formula, and we get this one. All right, I actually prefer this one because in this formula, it doesn't work when the probability of F is 0. That can't happen because you can't divide by 0. And that would be, you know, the number of elements in F is 0, the same thing. If that's true, well, I should just say it can't equal 0. This one, it'll work. So here we go. Let's put this into practice. The probability of E intersect F, which means the probability that they both happen, is equal to the probability of F times the probability of E given F. All right, here we go. In this example, we're going to draw 2 cards from a standard 52 card deck. And before I move on, I'm going to just ask a couple of questions. If I draw 2 cards, what's the probability that the first one is the 7 of diamonds? Well, it's 1 out of 52 cards. So let me start over with a brand new question. If I draw 2 cards from a standard deck, what's the probability that the second one is the 7 of diamonds? That's 1 out of 52 because I didn't know any additional information for that second card. If I knew what the first card was, then that would change the probability of the second card. Okay, and so that's what we're going to learn about right now. Use the multiplication rule of conditional probability, this thing up here, to compute the probability that the first card is an ace and the second card is a king. All right, there's some order. You know, we're going to end up thinking about this as the probability of, well, it's like a probability of one event followed by the probability of another event, and then we multiply those 2 probabilities together to get the probability that they both happened. All right, so what we have to find is the probability of ace first, the first card is an ace, and the second one is a king. That's what we're being asked. So you could think of this as being, let's see, looks like F would be the event that the first card was an ace, and then E would be the event that the second card is a king, because here we have the probability of the second card being a king given that the first one was an ace. So here's the way we do it in order. Ace on the first card, that's easy. We know how to figure out the probability that the first card is an ace. And then we also know how to figure out the probability that the second card is a king, given that the first one was an ace. What is, let's work it out down here, real simple. What's the probability that the first card is an ace? Well, how many aces are in the deck? 4. How many cards are in the deck? 52. So the probability that you draw an ace on the first card is 4 over 52. Now, given that that happened, what is the probability that you get a second card of a king given that the first card was an ace? Well, we already know the answer to this. How many kings are there? 4. How many cards were there? Not 52. The first card was an ace. So there's 51 left. All right, so we have this probability being 4 over 52. We have this probability of a king, given that the first card was an ace, as being 4 over 51. So we multiply those two probabilities to get the probability that both of those events happened. So it's going to be 4 over 51 times, sorry, I could done it out of order, but I want to do it in order. 4 over 52 times 4 over 51. That's the answer. And it's actually simpler. This problem is so simple, it's simpler to do it without even plugging into this formula. But on more difficult ones, you will want to end up using the formula. So once again, the probability of drawing an ace for the first card is 4 over 52. Now that ace is no longer available, so there are only 51 cards left, but there are still 4 kings left. So 4 over 52 times 4 over 51. And you could write that as a single fraction if you wanted to, but 4 times 4 over 52 times 51. On the exam, you don't even need to simplify that unless it says to simplify or write it as a decimal.